Hi, welcome back. Today we want to talk about comparisons. We've seen how a computer program can automate tedious chores, but it also can make simple decisions for you that can make computers much more powerful. So first of all, we have to talk about the kinds of decisions a computer can make. And they're essentially math decisions. And we've all done or use math to do simple comparisons. For instance, down here, if we look at this grayed out because I have it all commented out, there's some basic comparisons that would be familiar from your math classes. For instance, a less than 100 is a question. Is the variable a less than 100? If we come up here, we can see the variable a has been defined as an unsigned integer and initialized to 0. So this would be true, right? 0 is less than 100. Now, one thing about C is true is not, it just means the number 1, okay? And false is usually written as 0, but just means any number that is not 1. So this is a true statement. A greater than 100 would be a false statement. A less than or equal to 50 just broadens the category a little more, right? Is A less than 50, or could it be equal to 50? And then you have greater than or equal. Here is an important one for us, and it's different from what you would have seen in your math class. This is variable A equal to 10? Now, we used a double equal sign to emphasize the difference between asking the question, are two quantities equal or equivalent, and the assignment A equals one single equal sign equal to 10, which takes the variable and stuffs the 10 into it. Right? In math, equal is used for a bunch of different things. In computers, we need to use different operators for the two different meanings of equal signs. Okay? So you can say equals, but you probably should say equivalent rather than equals, because one of the most common mistakes in computing is to use a single equal sign here instead of the double equals. Now, I've been mostly comparing to numbers, but you certainly can compare to another variable. Is A greater than or equal to B? Well, A is 0 and B is 12, so that's definitely not true. Here's one that you may or may not have seen in a math class, but you might have seen it if you took a course in logic, and that's the not. Is the value of A, 0, not equal to 0? Well, that's false. So this exclamation mark is used to mean negation or not. So not equal to 0. Logic allows us to make more complex combinations as well. These are things like, is A greater than 8? And is B modulo 2? I should have got that written wrong. Is B modulo 2 equal to 1? Well, I should just point out that B modulo 2 gives you the remainder of dividing B by 2, right? And so B here is 12. Divide by 2 is 6 with no remainder. So B modulo 2 would be 0, and 0 doesn't equal 1. This is another way of checking if a number is odd. If I put it equals 0, it would be, is the number even? Equal to 1, meaning a remainder of 1, is the number odd. So is A greater than 8? No. And is the number odd? Both of them are no. So this is definitely a 0 as a combination, a false, sorry. Okay. The double ampersands That's how C represents the logical AND. We can also have a logical OR, where only one of them needs to be true. To make these comments a little clearer, I've put brackets around these guys, and that just makes it easier to see that there's one comparison here and a second comparison here. And finally, I've used a negation, so if A is not greater than 8 and this, you can make even much more complex combinations than this, but generally in the work we're wanting to do, more than 2 levels gets a little crazy. So this is the syntax for asking questions. And if you were saying this in English, you would say something like, is A less than 100? And so we want code to do that, right? And, you know, if A is less than 100, do this. Well, that's what's called an if statement or an if test. Here's our code the way it would be, right, for an if test. If whatever the comparison is. So I could take this and plug it in right here, right? So the if, here's the test we want to do, is A, the variable A is 0, less than 100. That's true. Then we should have code here that would execute. So easy code for us would be something like A is less than 100. But it could do much more complicated things in an if statement. Okay? What if A wasn't less than 100? What happens? Well, nothing, right? This if only proceeds if it's true. That brings us to the second sort of statement. That's known as the if-else or the if-else test. Again, you put in your comparison. So maybe it's A greater than or equal to B. Okay, and now in this if-else, if it's true, something will happen. But if it's not true, the else bit, something will happen. Let's make it simply print statements because they're easy to work with right now. Okay. And down here. So with the if-else statements, if something is true, something happens. If it's not true, something else is going to happen. Now with if-else statements, you could easily nest them inside one another to make much more complicated things occur. Okay. So here's an example of a nested if-else. Right? And it's set up so there'd be 3 comparisons. Right? So if comparison 1 is true, so maybe this is if A is less than 100. Okay. Okay. And then maybe this would be A less than 50. That could be our second comparison, right? Okay. And And so this is if A is less than 100, that's true. This would be the false. So if A is not less than 100, it might be if A is greater than 200. Do this, right? Okay. So you can have three different, and you can nest and nest and nest these things away. Okay? Right? So they can get very, very complicated very quickly, and they're very hard to read unless you keep indenting all the time. So, you know, if you get more than 3 or 4 indents, it gets very hard to read as well. So most people would probably stay away from nested if-else if they're more than about 2 or 3 levels, simply because they're so hard to read and understand, even with lots of good comments. I wanted to step back here to this if-else test and mention that the more complex comparisons can go in here as well, right? So you could certainly have something like that, where is A greater than 8 and is B an odd number? So we can certainly do that as well, right? So the comparisons can be complex. Your nested if-else statements can be very complex as well. I will go back to this and just change it to A greater than B. And let's just see if anything prints out, see if there's anything useful here. Give me some more room on the printout here. Okay. A is less than 100. A is not greater than or equal to B, right? So this didn't happen, right? Here it chose the right, sorry, A was less, so it was true. In this one, A wasn't greater than B, so it printed this. And we're not doing anything in the nested if-else statements.